geobyte.
Dear students, now let us discuss the previous year questions for the very simple unit, that is mechanical properties of solids. Okay, from this very simple unit you can expect one question for the NEET exam, that is the weightage of this particular unit for the NEET exam. Okay, I hope all of you clearly understood all the theory concepts what we discussed for mechanical properties of solids. Understood or not? Yes. Then let us take the very first question. Look at the very first question asking like this: the maximum elongation of a steel wire of 1 meter length, if the elastic limit of steel and its Young's modulus respectively are 8 into 10 power 8 Newton per meter square and 2 into 10 power 11 Newton per meter square. First, let us write the given data. Here, length of the steel wire, let it be L, 1 meter. Okay. Here, elastic limit means stress. Elastic limit, let me write that point. Elastic limit means stress. Generally, stress denoted with sigma. Therefore, the stress sigma equal to sigma given 8 into 10 power 8 Newton per meter square, and Young's modulus generally denoted with y equal to 2 into 10 power 11 Newton per meter square. You are asked to decide maximum elongation. Elongation equal to how much? Elongation. In fact, it is asking maximum elongation. Maximum elongation. Let it be delta L. Means change in length only, equal to how much? Okay. For that, as you know, the change in length delta L equal to change in length delta L is equal to uh, sigma L by Young's modulus. Okay. Here sigma is given. Sigma means stress. L is given. Young's modulus given. Let us substitute the values. It is equal to sigma 8 into 10 power 8. Length is given 1 meter. Take it in meters only. Y is 2 into 10 power 11. It is equal to, here we can cancel 2 4 times. It is 4 into, here it is 4 into 10 power 8 into 10 power minus 11. It is equal to 4 into 10 power 8 minus 11. It is equal to 4 into 10 power minus 3 meters. But look at the options. All options are given in millimeters. It is equal to 4 millimeters. Okay, look at the option D. Option D is absolutely correct. Understood clearly? Simple problem. Okay, similarly, let us take the another important problem asking like this. A metallic bar of Young's modulus 0.5 into 10 power 11 Newton per meter square and coefficient of linear thermal expansion 10 power minus 5 per degree centigrade, length 1 meter given, and area of cross section 10 power minus 3 meter square given, is heated from 0 degree centigrade to 100 degree centigrade. That means initial temperature is 0, final temperature is 100. Without expansion or bending, the compressive force developed in it is, wherever the heat is added or wherever the temperature is increasing, the metals are trying to expand. When you control that expansion length, some stress are developed in the bar. Those are called thermal stresses. That thermal stresses you can also call compressive stress. That compressive stress multiplied by area of cross section is giving the compressive force. That's what it is asking. It is given Young's modulus general Young's modulus denoted with y is given 5 into 5 into 10 power 11 Newton per meter square, and coefficient of thermal expansion alpha equal to 10 power minus 5 per degree centigrade, and the length is given, let it be L, 1 meter, and area cross section A equal to 10 power minus 3 meter square, is heated from 0 to 100 means change in temperature delta T equal to 100 minus 0, that is equal to 100 degree centigrade. Then compressive force equal to how much? You are asked to decide compressive force. As you know, compressive force compressive force due to temperature change equal to compressive stress compressive stress multiplied by area of cross section. Okay, here compressive stress due to temperature change equal to y into alpha into delta T, where y equal to Young's modulus multiplied by area of cross section. This is equal to y equal to 0.5 into 0.5 into 10 power 11, alpha given 10 power minus 5, change in temperature given 100 into area of cross section given 10 power minus 3. Substitute, simplify it. 0.5 into 0.5 into 10 power 11 into 100. I can say 10 power 13 into 10 power minus 5 minus 3, 10 power minus 8. It is equal to 0.5 into, listen carefully, 10 power 13 minus 8 is equal to 0.5 into 10 power 5 newtons. But look at the options given. It can be also written as, here it is, no, it can be written as 5 into 10 power 4 newtons. This is correct. But 5 into 10 power 3 is available. 50 into 10 power 3 available. The same I can write as 50 into 10 power 3 newtons. Look at the option A. Option A is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Look at this problem. Asking like this. The amount of elastic potential energy per unit volume in SI unit of steel wire of length 100 centimeters to stretch it by 1 mm is given Young's modulus. Here Young's modulus y equal to 2 into 10 power 11 given in Newton per meter square. The length L equal to 100 centimeters. It is equal to 1000 millimeters, because it is given the change in length delta L equal to 1 mm. Since change in length is given in mm, original length also taken in mm. Then here elastic potential energy per unit volume. Remember, elastic potential energy means strain energy. Indirectly, it is asking strain energy per unit volume. Okay. So let us write the formula for elastic strain energy, mean elastic potential energy. Elastic elastic potential energy per unit volume is equal to half into stress into strain. Stress into strain. That is the formula for the elastic potential energy per unit volume. But here, strain you can find it. As you know, the strain equal to change in length by original length. Let me write it clearly. Here strain equal to change in length by original length. And Young's modulus y equal to stress by strain. Stress by strain. From this I can write that the stress equal to Young's modulus multiplied by strain. Young's modulus multiplied by strain. It is equal to half into stress stress. Okay, in the place of stress, I can write, in the place of stress, I can write, stress equal to Young's modulus into strain. I can write strain square. Okay, it is equal to half into, look at the Young's modulus, 2 into 2 into 10 power 11. Strain equal to change in length by original length. Change in length by original length. It is equal to 1 by 1000. It is 1 by 1000 square. It is equal to half into 2 into 10 power 11 into 10 power minus 6. This 2 cancel. 10 power 11 minus 6 equal to 10 power 5. Energy, SI unit of energy is joule per meter cube. Volume unit is meter cube. 10 power 5 joule per meter cube. Look at the options. Option B is absolutely correct. Understood clearly? Yes.
Geobyte.